All right, welcome to the second lecture in Chapter 2, and this involves writing pseudocode, trying to get an idea of how I'm going to step by step move through a particular problem. The one that we presented at the beginning of the last lecture is the steps that it would take to calculate a restaurant bill. And so very quickly again, the first step would be to find out what the bill amount is. And then I need to determine the tax and the tip rate. And then based upon that, I need to calculate the tax and the tip rate. And then I need to add the tax and the tip to the bill amount, and then finally display that bill total to the end user. One of the things that I had you do when you were calculating a paycheck was I had you test it on a partner. And testing your code is critically important. I would say that testing your code is just as important as having a plan to write the code. It is important to have a plan to test it. Because if you just throw out a couple of different, I'm just going to test this, and I don't even know what it means to test, then you're going to have a code that could be very, very buggy with a lot of problems. And when you throw it out there for your end user, put it into production for people to use, you can have some code that is painful to use, this stuff. So I would encourage you to have some kind of a plan, a plan of attack for testing your code. So let's say, for instance, in testing, when you're planning to test your code logically, the first thing that you're going to do is you're going to find a bill amount. I would use a real, live, actual number. Then you're going to determine a tax and a tip rate. I would use real, live values. And then I'm going to break out my calculator. And I'm actually going to start calculating the tax and the tip using the real, live numbers that I have gotten, hopefully, from my partner. I'm going to add those together, and then I'm going to have some kind of a logical plan for displaying that to my user without just putting some random number on the screen. So you need to have a plan for testing, and this plan for testing needs to be a methodical sort of plan. And so you're going to notice in your Canvas that there, in the Getting Started module, there is a document in the Getting Started module called Developing Test Cases. So every program that you submit to me this semester is going to require a series of test cases. Because not only do I want you to, or want to know that you have a plan for writing your source code, I also want to know that you have a logical plan for testing your source code. It is irritating to me when people submit a program to me that doesn't even run, unless when they submit it to me they say, I know it doesn't run, I can't figure out why, I think the reason why it doesn't run is here, 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 and here. I think this is why, but I, for the life of me, can't figure it out. My second pet peeve is when people submit to me a code that does run but doesn't give me the right answer. So let's say, for instance, I told them I want you to write a program that calculates dog age. Now, to the best of my knowledge, dog age is calculated by taking your human age and multiplying it by 7. So if I key in my human age is 10, what should my dog age be? You're saying to yourself, after you broke out your calculator, you're saying to yourself 70. So I can't tell you how irritating it is to me to run a program, key in the human age of 7 or 10, and have it print out 145. Because then I turn to the student and I say, did you not even test your own code? Did you not even key in one single test value into your own program to make sure that it was working correctly? So as a part of your grade for every program, you're going to be giving me a series of test cases. And this is the format or the layout that I want the test cases to be in. You'll find this in the Developing Test Cases document in the Getting Started module. So I would strongly encourage you to use a spreadsheet format because it's the easiest to read. So let's look at example number 1. And this is a program that prompts the user for a number from 1 to 10, multiplies whatever that input is, and then displays the results. You're going to have a column that indicates which test number it is. You're going to have a column indicating what exactly it is you are testing right now. Because if you don't know what you are currently testing right now, how can you possibly thoroughly test your code? The next column is going to be input. If I only have one input, I'm asking the user for one thing, I only need one column. If I'm asking the user to give me 45 things, I would need 45 input columns. And then the very last column is the expected output. If I key in this value or this series of values, what do I expect to happen? So let's say, for instance, one of the first things that's good to test is something that is successful. So test number 1 If I ask him for a number from 1 to 10, I'm going to key in a number somewhere between 1 and 10. Let's say, for instance, 5. The expected outcome would be 10. Let's say the second thing that I'm going to test is number that is not from 1 to 10, something below 1. If you'll notice here is a -1. What is the expected outcome? I'm going to test something that is greater than 10, like 150 or 15 or even 11. And if I key that in, what would be the expected outcome? Now, based upon this particular program, I also have what are called boundary values. What happens if somebody keys in exactly 1 or exactly 10? You need to know that. I call them boundary values, and this particular program requires me to have boundary values. Now, you say to yourself, how do I know what's supposed to happen with those boundary values? My response is, ask the client. Now, because you're in class, I am the client. But if you're at work or you have your boss, maybe your boss is the client, maybe the person who is paying you to write the program is the client. The point is you go back to the client and you say, what do you want to have happen if they key in exactly 1 or exactly 10? And then I would have the expected outcome here. Let's say, for instance, you're the driver's license division and you're writing a program for drivers. And it says ages 16 and over. Well, what happens if they key in, or 16? Can 15-year-olds drive? Well, they can if they have a driver's permit, and so you need to clarify those kind of boundary values with the client. And then the last test case that you should always have is what happens if they put in some kind of a value that is not a number, because they will. You're going to say, give me a number between 1 and 10, and I swear there's going to be at least one person who will key in the preamble to the Constitution. So what happens if they key in a value that is not even a number? What is the expected outcome? All right, so that is the first example. Here's another example of several different inputs. Once again, I have a column that indicates my test number. I would have a column indicating each of the items that I am testing, and I would have a column indicating what would happen if they keyed it in. Now, it looks like we're asking them for 4 things. It looks like, based upon the output, that we are calculating their age in dog years and their weight on the moon. So I'm going to ask them for their first and last name. I'm going to ask them for their age and their weight. The beautiful thing about this is based upon the nature of their first and last name, I just need to test that I can key something in based upon the nature of the type of data that I would key in a first and a last name field. But with age and weight, there's a very good chance that they're going to key in, when I say, what is your age, that they're going to key in a number, something that is not a number, and the same for weight. So the first test that I'm going to do is successful. What happens if they give me all successful values? The second test case that I'm going to do is I'm going to try to blow up age. There's nothing that I can key in first and last name that would blow it up, because it accepts numbers and letters and symbols. And so I'm going to key in, or I'm going to try to blow up age. Then I'm going to get some kind of message indicating the fact that that is not a number. And then I'm going to do it again with weight. The one thing that I want you to be aware of, which will make more sense when we start coding, is that I have to have a valid value in age before I can ever try to blow up or put an invalid value in weight. Because if I blow up age, I will never even get to weight. And here is another example of a program that has some kind of decision or different paths. Let's say, for instance, that I am doing drivers. And anybody below 16 can't drive, anybody over 16 can drive. What I need to do now is I need to test both of those paths. I have just created within my program a path that goes down anybody less than 15, and I have a separate path that goes down anybody over 15. I need to have a test case for each one of those paths. Let's say, for instance, I wrote a program to calculate your letter grade, and say, or your age, 1 to 10, and 10 to 20, and 20 to 30, and 30 to 40. I need to test each and every single one of those paths to make sure every single one of those paths work. So I need to have a test case for each and every single one of those paths. This is a third example of logically creating some test cases. All right, so it's your turn again. What I want you to do now is I want you to write some pseudocode that calculates a grocery bill. Grocery stores come to you to write a program for them, for you to be able to add up someone's grocery bill. So you have someone is standing in line, they have one or more items. They may only have one, they may have 45. The idea is that you need to be able to have to add up one or more items in order to give them a total. But the twist is now you have to be able to add tax, or now your program should add tax on orders over $20. So if you say to yourself, I'm probably going to have to take into consideration this test, when I create test cases for this, I would probably want to test something under 20, something over 20, and that boundary value. That boundary is what happens if the order total is exactly $20. Based upon the software specifications that you see before you, what do you think you would do if the order falls at exactly $20? And then, of course, you're going to test it on your partner. So once you've had a chance to write the pseudocode, turn to your partner, and you're going to move through your pseudocode one line at a time, asking them questions, breaking out your calculator, and doing calculations and displaying totals. And then you're going to update your pseudocode as necessary. Once you've done that, you're going to create a series of test cases using the spreadsheet format that I showed you in that document in the Getting Started module. You're going to create an actual set of test cases for this particular program that you're writing now. All right, so the last thing that we're going to be learning about in this particular lecture is the idea of flowcharting. Because when I hire a architect to draw up the plans for my dream house, wow, they get out a ruler or a slide ruler, I don't know, and they're drawing lines and squigglies, and they have numbers in 3/4 of an inch, and they have some strange and bizarre things that are not easy for me to understand on that document. But what I want from them is I want them that 3D rendering. I want them to take those plans, that page after page after page of written plans, and turn it into a visual representation of my house. So I can spin it around and turn it on its corner, and I can see it from this view and from the top and from the bottom and from the front and the side, and I can pull the roof off and see the layout from the top. I like that visual representation. And we can do the same thing for our pseudocode. We can create what are called flowcharts. And flowcharts are just visual representations of the pseudocode that we have created. It gives me a visual, graphical way to view the pseudocode or the program that I'm about to write. So we're going to be using a flowcharting tool called Visio. I believe we're using Visio 2013. Depending upon the version of Visio that you're using, our symbols might look a little bit different. But in a flowcharting program, the shapes mean something. So for our purposes in the flowchart that we're about to create, if I want to indicate some kind of input from the user or output to the user, I'm going to use parallelograms. If I want to indicate some kind of behind-the-scenes processing that is going on, I'm going to use rectangles. Every program has to have some defined beginning and some defined ending. And we're going to use ovals to indicate those terminals, the start and the end of the program. And if I have any kind of decisions that have to be made, which might include or might add different paths or different flows through my program, I'm going to use diamonds to indicate those decisions. All right, so what we're going to be doing now is we are going to turn to Microsoft Visio. So if you open up Visio, we're going to be looking for something that says Basic Flowcharting. I just want a basic flowchart, and then if you'll notice down the side, it's going to give me a number of different shapes that I can use. And this should give me all the different shapes that I need. But if you find yourself needing more, in Visio I can always click on more shapes, and it will show me all the different categories available to me, or to this version of Visio, I should say. So, as I mentioned before, we need some kind of a start and an end. And so I'm going to grab this oval, and I'm going to drag it and drop it onto my screen. There it is. I'm going to zoom in so I can see it a little bit more. There it is. If I double click on it, once I've drag and drop it, if I double click on it, it allows me to type in what this particular symbol means, start. So what we're going to be doing is we're going to create a flow chart for the pseudocode that we created earlier. Let's come back up to it right here. This is the pseudocode that we're going to be flowcharting. The first thing that I need to do is find a bill amount. So I'm going to come back to my flowchart, and that would appear to be input or output from the user. So I'm going to use this parallelogram right here, which is a square tipped on its side. And from here, I'm going to type in find out bill amount. I could say prompt the user for the bill amount, ask for the bill amount. Somehow I need to indicate in here that I am getting input from the user. All right, so now let's look at one. We need to determine the tax rate and determine the tip rate. Are you going to ask your user how much tax they want to pay? Because if somebody asks me, I'm going to say 0.5%. And are you going to ask your server how much tip they want? Because if they ask me, I'm going to say 250% of the overall bill. So the idea is that I'm probably not going to be prompting my user for that. This is going to be some kind of an internal process to my program. So I'm going to put in here, determine, I should probably spell it right, tax rate. And then I'm going to drag another one onto my screen. And if you'll notice, it is a square because it indicates an internal process. Determine tip rate. Once I've done those two, and I go back to my pseudocode, the next thing that I need to do is calculate the tax and the tip. So I'm going to drag a couple of more of these processes onto the screen in order to calculate the tax and the tip rate. Double click on the next one. All right, then I go back to my pseudocode and I see that I want to add the tax and the tip to the bill amount. So I'm still internal to the program. I have something internal going on, so I'm going to drag a process onto the screen, double click on it, to add the tax and the tip to the bill amount. All right, so what is the next thing that I need to do? I want to display, once that I have calculated the bill amount now, I want to display the bill, the total bill to the user. But before I do that, there's one additional thing that I would like to add just so we get some experience with it, and that would be a decision. So the next thing I'm going to do is drop on this page a diamond to indicate a decision. Just to give us some experience with it, let's say, for instance, that your client comes back to you and says, oh, we want to give a 20% discount to anybody whose total bill is $250 or more. So what I'm going to do in this decision is I'm going to write, it's kind of like a question. The text that I would type in here would be a question, something like bill, or perhaps I should, to be consistent, I should use the word amount over $250. So I'm asking a question. And if the bill is over $250, I'm going to give them a discount. So I'm going to drop a process on here, and I'm going to say something like subtract, oh, did I say 20%? I was just about to type in 10%. Subtract 20% from amount. And then the last thing that I'm going to do is display the results, or display the total bill, which once again is a parallelogram. So I'm going to drop him on the screen, and we are going to display amount we call it total amount. Total amount. All right, so now I have all of the different symbols on the screen. I'm going to zoom out here a little bit so we can see all of them on the screen. I have visually representation. I can see the flow. I don't even need to be able to see what these things say. I can see automatically, but I have some kind of an input and output. I have a bunch of internal things that are going on. I have some kind of decision, some kind of a decision that needs to be made that is going to change my path one way or another. The next thing that I need to do is I need to come back and I need to connect each one of these different symbols. So I'm going to zoom in again. I'm going to come back up here to the top. I have zoomed in too far. We're going to come back to the top, and now I'm going to be adding connectors. So across the ribbon at the top, there is something called tools. And if you'll notice, the one that is currently highlighted right now is a pointer tool. Immediately below that is something called the connector tool. And if I click on it, now, instead of having a pointer as my cursor, I now have the ability to draw lines between each one of the individual symbols on the screen. So I can hover over a symbol and I can just drag to the symbol that I want to connect it to. So I'm going to connect each one of these based upon the path that my program is taking. When I get down to this decision, I have the ability to go two separate directions. One of the directions is, I'm going to highlight this and I'm going to drag him to this box. One of the directions is yes, the bill amount is over $250. The next path is no, it's not over $250. And then the final connection that I'm going to make is between, if it is over $250 and I give him a discount, I still need to display the total. And there's one additional item that we need to add. I'm going to go back to my pointer tool, and I'm going to add my end, because I need to have some kind of a defined end. So I'll double click on it, type in the word end. Then I'm going to go back to my pointer tool, and I'm going to drag the last and final line down to my defined end. Now I have this decision with the question, kind of, is the amount over $250. I have the results of the flow of my program depending upon the answer to that question. The last thing that I want to do is sometimes the answer, the flow that I need to follow is not necessarily obvious just based upon the question and the flow itself. So if I double click on a connector, I can type in the answer to the question. Amount over $250? Yes. I'm going to double click on this line. Amount over $250? No. And now I can see the answers to the question. It makes the path or the flow a lot more obvious. So if I zoom out one more time, we can see the flowchart, or the graphical representation of the pseudocode. And it makes it very visual, much, much easier to follow based upon this graphical representation. All right, so your turn. The last thing that I'm going to have you do is I'm going to have you write a program. A university has come to you and said that they need a software program that allows them to assign students to a dormitory. So you are sitting at a desk with a laptop on the desk, and you have a line of students that are waiting to be assigned to a dormitory based upon their last name. If the last name starts with the letter A through M, they will be assigned to Chestnut Hall. If their last name starts with the letters N through Z, they will be assigned to Hare House. Your program has to have the ability to assign more than one student. Not at a time, but you have a line of students at your desk, and one at a time those students are going to come up to you, and you need to assign them to the appropriate dormitory. So I'm going to have you write the pseudocode to do this. Somewhere between 3 and 20 steps is necessary for you to write it. I'm going to have you test it on your partner. Line by line by line, test it on your partner. Update your pseudocode as necessary. I'm going to have you create a series of test cases in a spreadsheet format. And finally, I'm going to have you create a flow chart that shows the flow of the pseudocode that you wrote in the first series of steps. Once you have done that, you will have had quite a bit of practice in doing some pseudocode. This may be your first experience with test cases and flow charting. But your homework assignment for this week is going to be to write some pseudocode, some test cases, and flowcharts. So let's go back to the Canvas class and review this homework. All right, so in Canvas, Chapter 2 assignment, you're going to create a series of flowchart or pseudocode, flowcharts, and test cases for the following 3 programs, 1, 2, and 3. So if you read through the instructions for each one of the 3, I want pseudocode, I want a flowchart, and I want test cases for each one of the 3. Let me know if you have any questions. And this is the end of the lecture.